Okay, so in this video we are going to look at something called triacylglycerides, and the questions on this are always answered really badly, and I think part of the reason for that is well, if I just that's what a triacylglyceride looks like, and it looks very complicated, but hopefully, and people just, I don't know, they just don't bother with it and just don't revise that bit. I hope it will go away, but it's not as complicated as it looks. We'll build it up step by step, see what happens. Okay, so please do make an effort with this, and so when I'm marking your papers, that I don't get depressed by everyone getting it wrong. Okay, so triacylglycerides, right? These are fats that you find in biology. Okay, so if you do biology as well, you probably know about a little. You know about these. You know that a triacylglyceride, it gets digested, and in biology, it's usually a triacylglyceride, or sometimes it's called a triglyceride. So these are, your fats these are animal fats, or in olive oil. Olive oil is, or rapeseed oil, whatever. It's all made of triacylglycerides, and when you digest them, you have an enzyme called lipase, which you don't need to know about that for chemistry, but I'm just trying to make links to your biology, and that will break it down to glycerol. And you probably recognize this in biology, 3 fatty acids. And you think, well, what on earth is that all about? Okay, right. Well, glycerol is an alcohol. Okay, it is an alcohol, but it hasn't just got one alcohol group. It's got 3 alcohol groups in it. Okay, and it is propane 1,2,3 triol. That's its formal name. Okay, so it's got 3 OH groups on it. So each one of those OHs, well, they can form esters, and each one of them forms an ester with a carboxylic acid. So that's why you get this 3 acids bit. So what's the fatty bit mean? Well, a fatty acid, what do the 2 bits of the word mean? Well, this bit is a carboxylic acid, and this bit just means a long hydrocarbon chain. It's non-polar, and that's sometimes you call non-polar molecules fatty. Okay, you know that fats won't mix with water, will they? Right. So a typical fatty acid would be 1, and they're usually pretty long. They're typically about 16, 18, or 20 long. It's always even numbers in nature, which is interesting. That's because they're built up out of units, 2 carbon units. So that's why you never get the odd numbers. So that's, say, 16 CH2s. Save us writing out like CH2, CH2, CH2 16 times. And then you've got a carboxylic acid at this end. Okay, and all that happens is each one of those OHs in the glycerol, in the propane 1,2,3-al, or the glycerol, right, you're going to lose that there, aren't you? You're going to lose water there, so you're going to form an ester linkage. That carbon is going to join up with that one there. Okay, and you're going to lose water. So that is how, right, this is the reverse of this reaction, how you build up a triacylglyceride from glycerol and 3 of these fatty acids. The fatty acids don't all have to be the same, so you can have that one could be like 16 long, and then the one that's attached to this oxygen might only be 14 long. The one that's attached to this oxygen could be 16 long, 18 long, but it might have a carbon-carbon double bond. Then it might be an unsaturated thing, like be an unsaturated fat. Okay, so let's try and draw a triacylglyceride. Right, so that was what I started off with. Okay, I'm gonna leave that there and just build it up. So first of all, we want to draw propane 1,2,3 triol, and it's probably easiest if you draw it in. Let's do it in red. If you draw it sideways on. Okay, so we're going to have 3 carbons like this. They're just going to have H's attached everywhere. can see here where I've drawn them H3C rather than CH3, because then you can have, if you put the CH3 there, then it looks like the bonds coming from the hydrogens, and we've seen that's not going to happen. That's why people draw this H3C bit sometimes. And we're going to have 3 alcohol groups here. Let's draw a fatty acid in green. We'll make this one 16 long. Sorry, 16 long yet. So I've got 14 CH2s and a CH3 on the end. Let's make this one 18 long. So this next one. So that's got to be a 16 there. And then finally, so that would be 18 carbons long. Octadecanoic acid is sometimes called stearic acid. And then let's say this last one. I can't be bothered drawing one with a double bond in it. It's too complicated. Let's have another one that's 18 long. Stearic acid, CH3. So what's going to happen there? Well, we're going to the mechanism that oxygen would attack that carbon there. Yeah, we're not really worried about the mechanism here. So we're just going to say, right, we're going to lose this water molecule here, and we're going to lose this one here, and this one here. Okay, so I'm going to put 3 water plus 3 H2Os there, and I'm not going to draw the whole thing all over again because it take too long. I'm going to rub this bit out and make this a rather long oxygen carbon bond. Do the same here. That's the oxygen from the alcohol, which ends up in the ester linkage. Do the same here. Okay, and this is our triacyl glyceride. Okay, that's a fat. Right, we need to know these triacyl glycerides are converted into 2 useful products, and we need to know about each one. Right, so let's clear that and write down what they are. Okay, so triacyl glycerides. Right, if you make them undergo alkaline hydrolysis, okay, so if you put NaOH there, you're going to end up with basically you're going to end up with soap. Okay, so, and you'll also get glycerol. Well, how does that work? Well, what happens is soap is made up of, you hydrolyze the ester linkage, so you get the carboxylic acid like that. But of course, because it's an alkaline solution, you would never, if it's an alkaline solution, you're never going to end up with this hydrogen intact. The OH is going to remove that, so you end up with not the carboxylic acid, but it's sodium salt. So that's the negative ion, and you'll end up with an Na plus ion there. Okay, so that's soap, and this is the molecule. This has the ability well, the way it works is this is hydrophobic, and this is hydrophilic, this bit of the molecule, because it's charged. Okay, charged things tend to be soluble in water. So if you get a blob of fat, so here's a blob of fat, what happens is these hydrophobic tails, they stick into the fat like that. And what sticks into the water, so this is all water outside here. What sticks into the water is the negatively charged hydrophilic head, which is all like that. Okay, so it breaks the fat up into lots and lots of tiny little droplets like this, and that's how soap works. So it washes the grease off your skin. It kind of effectively solubilizes all the fat molecules, so they can mix with water. If you try and wash, greasy plates with no soap, with no detergent, it won't work with it, because they don't. But it does work when you add detergent, because you form lots and lots of these tiny droplets called micelles. So you can form soap. Now the other thing that you can form, and we'll do that in more detail in another video. The other thing that you can form is biodiesel. Okay. Now biodiesel, what happens is you get all the fatty acids, and you break them away from so you hydrolyze the ester linkage, yeah. So you get rid of the propanol, and you form a new ester, this time with some methanol. So you've got to add methanol. So that red bit's come from the methanol. So you add methanol. So you'll form 3 of these methyl esters instead of one big triacyl glyceride. You form like these are methyl esters, and that's what biodiesel is. Presumably, I don't know for sure, but I think the reason they do that is obviously what's going to happen to the molecular weight as you go from the triacyl glyceride to here. The molecular weight is going to be smaller. That means it will be less viscous, weaker intermolecular forces, and the boiling point is going to be lower, so it may be a bit easier for it to. So that's simply what biodiesel is, these methyl esters, and they can go straight into a diesel engine, and they don't wreck it or anything. Apparently it's perfect, and they can turn old chip fat into diesel that they use in taxis. You've probably seen videos or in the news about it or something. So anyway, we talk about these 2 processes in a later video. Okay, but we'll leave that there for the time being. And please, the only way, I've got to rub it out, but the only way to really get your head around this is to draw that awful complicated triacyl glyceride molecule. You might want to also draw it in skeletal formula. Well, I'll just draw it before we finish. Let's draw a skeletal formula, triacyl glyceride. So here is going to be the propanol. You've got 1, 2, 3 carbon atoms for the propane. You can have, actually I'm going to draw it that way around. See why in a minute. Sorry. Okay, so you've got 1, 2, 3 carbon atoms, right? You're going to have an OH there, an OH there, and an OH there. Here's going to be a fatty acid, so it's going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Make that one 14 long, and it's going to have a carboxylic acid group at that end, right? So that's going to form an ester here, isn't it? Yeah. So if I just draw now what the finished thing is going to look like, it's going to look like you've got your final carbon with the with that on it, with the O, and then you're going to have all the other ones there like that. That one is going to go, so I'll draw it the same way round. So that you've got a carboxylic acid, you've got the carbonyl there, and then you're going to have this bit, and the same there. So I would practice drawing those, try and draw them from memory. And when you get stuck, cheat and have a look at the video again, and then close it and try and draw it from memory until you can draw it from memory, and then it's not really that difficult. Okay, let's end the video there.